All right, so here's a problem. We want to draw the shear force and bending moment diagram for this frame. These problems just take a little bit longer. I don't know if I'll be able to finish it all today, so this may come in installments like a part 1 and a part 2. So first thing we need to do is find all of our reactions, and then we want to use method of sections and find out what's happening here at B and C. So that's going to take us a little time to do, so let's get started. So at A, I'll assume AY and AX. And over here at D, I'll do dy. And let's find those. So I'll start with summing moments about A and make sure that's in equilibrium. I'm using right-hand rule for my sign convention. Before I get too much farther along, let's get the concentrated equivalent force for this. So this is 3 kips per foot over 12 feet, so that's 36 kips. And halfway up would be at about 6 feet. So that's the data I needed to do that to sum my moments. So about A, the concentrated equivalent force is creating what kind of moment about A with my sign convention? Negative. What about this 15 kip force up here? Positive or negative? Negative. And then dy would create? Positive. So let's write those down. So 36 kip force, 6 foot moment arm, negative moment. 15 kip force, 4 foot moment arm. And then a positive dy, and its moment arm is 8. So what is dy? I'm going to need some help with that.
That'll be negative, not negative, positive 34.5.
34.5. Anybody else get 34.5?
34.5.
Yep.
You can always start, like if you were to do that this problem or a similar one, you always start from your moment about the left side.
I started about the pin.
About the pin?
Yeah.
So is there a problem with starting it about the
In this problem, no.
But some problems it would.
It is problem dependent. So you could easily have some moments about D and gotten AY.
Because I like doing.
Well, here's an example. What if this leg of the truss was? The frame wasn't 12 feet; it was 10 feet. So that this reaction was actually up here. Well, if you sum moments about D, both those would create moment. If you always sum about A, you know there's 2 there. So with determinate problems, there's only going to be one unknown. So it's kind of like, it's not a rule, but it's a real good method, I guess a practice, best practice type thing. All right, let's go ahead and get this finished up. So let's find the other reaction. So I'll sum forces in the y direction. So I have AY acting up plus dy and minus 15. So what is AY? I think that will be negative.
Negative 19.5.
19.5? Anybody else get that?
Yes, 19.5.
Does it make sense that AY is down? Well, the current situation with all the hurricanes battering the East Coast, when you have a big horizontal force like this, like a big wind force, it's going to try to pick the whole building up and rotate it clockwise. So this anchorage here at A becomes super important. And if you haven't designed your building to be able to handle uplift like that, in excess of maybe the gravity load, you can have big issues. So one of the big problems in high winds, especially hurricanes, with sustained winds, is it'll just pound your building and once it rips off the roof, then lots of bad things start to happen. So, tragically, something to think about. We'll finish this off by summing forces in the x direction. And in many cases, these frame problems, the x component of the reaction is not necessarily 0. We have a big horizontal force, so that's going to take care of it. So we have AX acting to the right, and we also have this big horizontal force acting to the right. So it looks like AX is minus 36. Okay? So now we have our reaction, so let's go back and take it apart at B and C. So let's think about that. If you did take it apart and look at a free body diagram of B and C, you would have all these forces to deal with and the 3 at B. You could do that. If you went to B and C, you would have 3 at B and an additional 3 at C. So BC is not a good place to start. But over here, all by itself, CD looks like a great place to start because I got 3 unknowns at C. Should be very easy to solve for that. So I'm going to start with that. So I'm going to look at section CD. So if I draw a free body diagram for that, I think you'll see this is going to be pretty easy to do. So dy is up, and it was 34.5 kips. There are no other forces applied to it. And then at the section, I'm going to assume a positive CX, a positive CY, and a positive moment at C. Now, getting back to an earlier comment, where's a good place to sum moments when you do set up for sections? Pretty much always at the section. So let's do that. So we'll sum, again, using right-hand rule, I'll sum the moments, and the section I cut was at C. Make sure it's in equilibrium. So using right-hand rule, this moment's positive. And what else do I have? Anything else create moment about C? Nothing. So the moment at C is 0. I'll sum forces excuse me, in the X direction. And all I have is, looks like all I have is CX. So CX is 0. Now I could go ahead and sum forces in the Y direction to get my CY. But for this element, it really doesn't matter because if I'm drawing the shear force and bending moment diagram, all I would care about would be the shear forces, which are in the X direction here, and the moment. So right now, if I want to draw the shear force and bending moment diagram for CD, I can. It's basically 0. But I know that CY, even though it's an axial force on this body, is going to become what in BC? A shear force. So let's go ahead and get it. So I have CY acting up. Also the reaction force of 34.5 kips acting down. So CY is negative 34.5 kips. So this element is in compression or tension?
It is in
compression.
Okay. That's what I meant to say.
All right, so we have just enough time to finish the equilibrium. So now that I know everything at C, I need to find everything at B. Now, would you like to work BC or AB? It shouldn't matter. Which one will present you the least amount of effort?
BC.
I think BC. Now, there is an argument to be made that my answers for B using BC will involve previous calculations at C. So if you do make an error at C, it's going to affect it here. If I did work AB, then my solution at B would not be affected by, say, an error at C. So there's possible strategy there. But I feel pretty good about these, 0 and 0. So I'm going to go that route. So now I'm going to draw the free body diagram for BC. It has a 15 kip force right there in the middle, 4 feet, 4 feet. Okay, at C I have no moment, have no X force, but I do have a Y force. So in this case it was up here, but it's negative, so it's down here, so it's going to be up on this side. And then I'm going to assume over here positive in the Y direction, positive in the X direction, and with my right hand rule I'm going to assume my moment is positive there. So I just need to find those values. So it's a good place to start. I think so. So we'll start at B. So again, we'll sum moments using right hand rule as our sign convention. We'll sum moments at B and set it equal to 0. So that means the moment at B, the way I've drawn it, is a positive moment. This 15 kip force about B, is it positive or negative? Negative. So that'll be force 15 times distance 4. And then this guy over here is going to create positive or negative moment about B. Positive. And that's 34.5 kips for the force, and the moment arm is 8 feet. So what is the moment at B? Looks like it's going to be negative. Is that right? I know that. That's 60. I don't know what that is off the top of my head.
The moment at B is going to be negative 216.
216?
Negative.
Anybody else get 216? One more? You need a trifecta. Oh, you gave me the thumbs up and you don't even have a calculator. Are you Rain Man now?
No, I sound good.
Oh, so you trust him.
Yeah.
That's not good. All right, so negative 216. Let's sum forces in the X direction. Oh, I said X, but I meant Y, sorry. So that's BY acting up. Minus 15 is down. And my reaction on the right-hand side is up. So what is BY? Is that 19.5? Yeah? Negative? I think so. And then last, we'll sum forces in the X direction. And all I have on this body is Vx. Okay? So we'll have to stop here because class is running late. But I'll pick up here. Oh, I guess it'll be in a week because we won't have class next Tuesday. So I'll refresh your memory on this, and then we'll draw the shear force and bending moment diagrams.